Look at all those people. Oh, crap. Fowler's here. I gotta be careful what I say.
Welcome, everyone. I'm James Shore, and this is the Art of Agile Development Book Club. Today, we are discussing evolutionary design, one of the most important ideas in Agile and one of the least understood. We are incredibly fortunate to have Kent Beck joining us today. Kent is the creator of Extreme Programming, the groundbreaking Agile method that introduced evolutionary design, test-driven development, continuous integration, and many other Agile practices to the world. It's the basis of most of the material in the Art of Agile Development. Kent finds joy in programming and teaching programming and describes his mission as helping geeks feel safe in the world. You can find his writings about design at tidyfirst.substack.com. Kent, welcome.
Thank you so much, James. What a pleasure to see you again after far too long.
Yeah, same. I'm going to get things started by reading an excerpt from The Art of Agile Development. As a reminder, the second edition is now out in both ebook and print editions.
And it makes an excellent gift.
You can get it from Amazon for that gift by visiting jamesshore.com/s/buy-AOAD2. And you can find excerpts and bonus material by visiting jamesshore.com/s/AOAD2. Chapter 14, Design. Software typically becomes more expensive to change over time. I'm not aware of any good studies on this, but I think it's something every programmer has experienced. When starting on a new code base, we're incredibly productive. But as time goes on, changes become more and more difficult. That's a problem for Agile. If change becomes significantly more expensive over time, the Agile model doesn't make sense. Instead, the smart thing to do would be to make as many decisions as possible up front when they're the least expensive. In fact, that's exactly what pre-Agile methods tried to do. For Agile to work, the cost of change must be relatively flat or even decreasing over time. Kent Beck discussed this in the first XP book. A flat cost of change curve is one of the premises of XP. It is the technical premise of XP. If a flattened change cost curve makes XP possible, a steep change cost curve makes XP impossible. If change is ruinously expensive, you would be crazy to charge ahead without careful forethought. But if change stays cheap, the additional value and reduced risk of early concrete feedback outweighs the cost of early change. Extreme Programming Explained, first edition. But as we've all experienced, the cost of change isn't flat. It does increase over time. Does that mean that Agile teams are doomed to collapse under the weight of unmaintainable code? The brilliance of XP was that it included practices to proactively reduce the cost of change. Collectively, these practices were called evolutionary design. XP remains the only mainstream Agile method to include them. That's a shame, because without evolutionary design, Agile teams do collapse under the weight of unmaintainable code. I first heard about evolutionary design in 2000. It sounded ridiculous, but I respected the people recommending it, so I tried an experiment. My team was just about to start a new project. We started with a traditional upfront design, then applied an evolutionary design from that point forward. It worked. It worked incredibly well. Evolutionary design resulted in steady improvement, giving us a design that was cleaner, clearer, and easier to change than the upfront design we started with. I've been pushing the boundaries of evolutionary design ever since. Skip ahead. Traditional design starts out fast when everything's a clean slate. Evolutionary design is the opposite. In the beginning, you're still feeling your way around, evolving the design as your team has new ideas. But then traditional design slows down, and evolutionary design speeds up. After about 4 to 6 weeks, in my experience, the curves have crossed. Code built with evolutionary design is faster and easier to work with than traditional code of the same age, and it keeps getting better. Evolutionary design is essential to long-term success with Agile. It's revolutionary, and barely anyone knows about it. So that is evolutionary. Thanks, Kent. Let me let some more people back in. Let's go ahead and get started with our first discussion prompt. Evolutionary design starts out simple, as you well know, Ken, and then you evolve and improve the design in response to new features that you want to develop. But what does that as simple as possible really mean in practice? Does that mean that you're not looking ahead an hour or a day, a week, a month? What does it look like in practice?
So, James, this is something I had to learn for myself, and I would urge everybody to do this experiment. Um, and I did exactly this experiment. I was very proud of my ability in my 20s to view the shape of the design in through 2 years hence and do everything necessary to make the design perfect for the next 2 years worth of requirements. And at some point, I actually stepped back and I noticed, well, many of the design decisions that I made, the requirements they were there to support never appeared, or I learned a better way to do the whole thing, and I had to undo a bunch of stuff. And well, this is just wrong. But plus, there was tons of anxiety. Like, is this really the right decision? And the more I learned, the greater that anxiety grew. So, as a mental health measure, I decided I was going to ignore requirements that were more than 6 months in the future. And I noticed that my designs got simpler. I got started faster. I got feedback from real users sooner. It was easier to explain to other people. It was easier to evolve in unexpected directions. And most importantly, my anxiety dropped. So I looked less far in the future and I did a better job of designing. What if I cut that to 1 month? So I cut it to 1 month and my designs were even easier to explain, more adaptable to change. I got feedback from users faster and my anxiety level dropped again. No, this is like all the books say the way you properly, responsibly adult design is you look far into the future to make sure the cost of change doesn't eat you up. And I'm experiencing exactly the opposite. So, what if I cut it to a week? Same effects. I cut it to a day. If I'm not implementing this today, I'm not going to make a design decision that supports it. The effects increased. I went, all right, well, forget this. I'm just not going to make any design decision until after I have the code implemented that needed that design decision. Then I'll make the design decision. That's dumb. That'll never work. And it worked. I don't want anybody to take my word for this. I want everybody to do this experiment. Because the conventional wisdom that the larger that design decisions are assets, and the more of them you make, the more valuable your software is backwards. The more design decisions that you make, the harder it is to make changes. So limit the number of design decisions, but find your own sweet spot. Maybe you have to look a week ahead. Maybe you have to look a month ahead. Maybe you don't have to look ahead at all, but do the experiment yourself. Don't just assume that whatever spot in the trade-off space that you're currently occupying has to be the best possible one. Does that answer your question, James?
It sure does. I love that phrasing. Well, I love two things about what you just said. First off, I love the emphasis on conducting an experiment, because I see so many people say that could never work, and then they turn off their brains and they walk away. And then the other thing that I love about what you said, and this is the first time I've heard it phrased in this way, is that it reduced your anxiety about the design, which is so true. And I just love that expression. To join the conversation, just raise your hand in Zoom. I'd like to invite Paul on up. Paul, welcome to the show.
Thank you. I was curious. Oh, hopefully I'm unmuted. And good. Whether your experience around the company and the risk level changes the way you would approach the design. Like, what does risk play in, or that word, or does it at all?
The risk of what?
Risk of making mistakes, or risk of impacting the client using your software. Okay, I'm thinking of the dynamics of, let's say your software goes in a Boeing 787, versus your software is a Facebook newsfeed. Like those are pretty far dynamics, right?
The one can only kill the 400 people, and the other one can potentially kill billions.
Right, exactly.
Okay, fair enough. So I make a strong distinction. I'm not the only one who does this, but I make a strong distinction between reversible and irreversible decisions. And I have a piece up early on in the XP days. Professor Zananotto, a dean of economics at University of Trento, actually explained why this all works. And it is about XP takes advantage of reversible decisions. Structured decisions, most structured decisions in software are easily reversible. And if you have a reversible decision, you can just try it, and if it doesn't work, you untry it, and away you go. So all these design decisions that we're so very carefully making upfront so that they're cheap to change, well, if they're wrong, if they're reversible, we don't care. And so we can leave them as late as we want. Those are completely different. I work now at Gusto, which does prints 1 million paychecks a month. And those are irreversible decisions. If we print the wrong paycheck, if we report the wrong numbers to a taxing authority, all of a sudden undoing that becomes a huge, huge deal. Now, it still happens, but we are very, very careful with those decisions. Do you have to pay that same kind of attention to design decisions? No. Because if I extract a helper method and you don't like my helper method, you inline it, done and dusted, who cares? So I want to make that distinction very strongly, and I want to treat design changes totally differently than I treat behavioral changes. That's one of that was one of the things that jumped out to me as I began writing this book, Tidy First, was that there is a strong distinction, and I want to treat them very differently. And so I want design decisions to stand alone, because I can just rubber stamp them, because if I don't like them, I just undo them. Now, what that lets you do is it lets you apply all of your creativity and energy to the behavioral changes that you're making in the system. And that allows you to do a better job of reliability and reduce risk by introducing more feedback loops for the behavior of the system. Because you have all that time that you're not stressing, excuse me, about the design decisions that are easily reversible anyway. Now, there are design decisions that aren't easily reversible. You extract a microservice, inlining that microservice, like the extraction of it is likely to be expensive, and the inlining of it, given the current set of tools and techniques and social structures we have, is likely to be expensive. Now that sounds like a market opportunity to me. You know, select some code, extract microservice, inline microservice. Well, our IDEs should support this, but they don't. So that's an irreversible design decision, and that requires more forethought than the kind of smaller scale design decisions that I'm usually talking about. Does that answer your question?
That's great, and maybe to label something that maybe you're implying, is it really about the interfaces? Like those are the things that are like pretty irreversible, or
no, they're not.
Like
no, because I can
the general idea of the interface and then the implementation are.
Well, that's certainly a distinction that I make strongly also. Now, so changes within an interface that don't affect the outside world, that aren't coupled to other elements. So in my parlance, I would say design is about beneficially relating elements. So you got these elements, whether they're services or functions or modules, and they have relationships, and the relationships create benefit. So this service handles this problem, so this service can just ignore it. Okay, so design is about creating and destroying those elements, creating and destroying those relationships, and increasing or decreasing the benefit of the relationships. Interfaces is about that relationship between two elements, and the elements themselves are subject to change inside, but the relationship is subject to change also. And you're going to learn about that, and you'll have made some decisions that were locally effective in the past that are no longer locally effective. I'm afraid I've spun off into kind of abstract land here, so I'm going to stop right now and see if you have any feedback or if we should just go to the next question.
Well,
James,
Paul,
it's your show.
I say let's go on. This was great. It helped me, anyways.
you've fallen off my
Stay
list for some
hydrated,
reason.
people. Kidney stones really hurt.
All right.
There.
Thanks.
Now
thanks
you
again,
have
Paul.
value out of this whole thing, and you don't have to listen to any of the talk about software.
Just
You're-
stay hydrated. That's the one
You're
that really
welcome.
matters.
No, there's reasons. But anyway, go ahead.
Reuven is up next. Reuven, welcome to the show. Again, to join, just raise your hand on Zoom and you can join the conversation.
Yeah, hi, do you hear me?
Yeah,
Yes.
you're coming through.
Yeah, hello. I always thought about the mantra, you ain't gonna need it, that you meant only about features, not about design. Now, when I heard you, now I think differently, that even for design, you don't need to do any step further. Would you agree?
Yeah, 100%. So I'll tell you the story of me coining "you aren't going to need it." We had a very smart, very effective engineer, very experienced engineer on the original C3 project. And we were a few months in. This is Chet. It's Chet's fault, that Chet. We were a few months in, and he came up to me and said, okay, so we're going to need to do blah, 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 so I need to do this and this and this. And I said, Chet, you aren't going to need it. He said, no, you don't understand. For sure, we need to blah, 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 blah. I said, you aren't going to need it. He said, no, you don't understand. He was getting agitated. Blah, 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 blah. I said, Chet, you aren't going to need it. He went, oh.
So this was designed already by then.
Yeah, it applies to behavior changes and feature and structure changes. Absolutely.
Okay, thank you.
It's not true. It's not a statement of you aren't actually going to need it. It's a most of the time the best way to act is as if you aren't going to need it. If you do need it, that's different. Sure, implement it. But if you might need it in the future, you know, what's the horrible thing that's going to happen if you just put it out of your mind at the moment? And that's an experiment, and I wish everyone would try it for themselves. Don't take my word for this. That would be ridiculous.
Yeah. So have you tried this experiment? Have you tried reducing the amount of time that you think ahead, of reducing the amount of things that you are sure you're going to need? If you have, go ahead and raise your hand. Reuven, thank you very much for your comment. I'd like to switch gears for a moment, Ken. Let's talk about code smells. We had Martin Fowler on a couple of weeks ago, and he said that you had two major contributions to the refactoring book. The first one was teaching him refactoring in the first place, and second was in your flat in Switzerland. I think you said you both had some whiskey and came up with a whole bunch of names for code smells. So this is, of course, is one way to identify how to evolve a design. What code smells do you feel are particularly pungent, and how do you use them when you're looking at some code that you want to change?
The ultimate code smell is having to change two places at the same time. And in fact, later today, I'm talking to my friend Massimo Arnoldi, who introduced me to the concept of code smells. Wow, there's a lot of ways I could take this answer. So the one I'll start with is code smells is a way of engaging your aesthetic sense in software development. We think of ourselves as very right brain, linear, logical, rational thinkers, but there's a whole lot of software development that's feel and judgment. And code smells are a reminder that aesthetic concerns are real concerns. And So I like the more of me that's engaged in the software development, the better job that I do. That's why I take care of my physical body. My chiropractors introduced me to a balance board, which is really annoying because I keep falling off. I want to be emotionally present, physically present, and intellectually present when I'm developing software. Code smells is a reminder that that aesthetic sense, ugh, this just looks ugly, matters. Now, maybe I don't do anything for it right now. Maybe I put it on the fun list for later. But, and this is the whole point of the book. The book I'm working on, the first in this series on software design, is called Tidy First ? About exactly this moment where you're like, ugh, this is harder to change than it should be. Maybe I should make it easy to change before I change it. And the answer is sometimes yes and sometimes no. And the factors that that question depends on are basically all of software design. All of the economics of it, the psychology of it, the sociology of it, the anthropology of it, the mechanics of it, and so on. And Tidy First is addressing that at the smallest possible scale.
I'm really looking forward to seeing Tidy First when it comes out. I've just learned about it recently, and I've always appreciated your perspective on design. If you haven't read, I believe your rewrite of your Smalltalk book is called Implementation Patterns. Is that correct?
Correct.
Yeah.
Uses Java and that family of languages.
So for all of you in the audience, if you haven't gotten a copy of Implementation Patterns and read it, I highly recommend it. Kent's musings and thoughts on design are always worth reading. Once again, if you'd like to participate in the conversation, just raise your hand on Zoom. I'd like to invite Steve Kuo on up. Steve, welcome.
Hi, James. Kent, everyone. You asked a question if you've tried this experiment using evolutionary design and had success with it. Yes, a number of people here were on a team where in 3 months, we delivered about 13 prototypes in Azure to get a healthcare provider in Washington State to the cloud. We didn't know Azure when we started, and we just had a little bit of an idea of the design. So in this case, plans are everything, or planning is everything, plans are nothing. And we evolved a design that was finally accepted by security after 13 full working prototypes.
Fantastic. Thank you for sharing that, Steve. I'd like to invite Franz on up. Franz, welcome to the show.
Thank you. Kent, you're talking about the aesthetic side of design decisions. I totally agree with that, but I've run into a phenomenon associated with that I think is worth noting, which is that I think that when I talk to non-programmers about design issues, I feel like I have to translate away from that aesthetic language, because I say things like, oh, the code's ugly, or the code's, nasty, or sort of aesthetic words. I want to make it cleaner, or in your case, I want to make it tidier, or things like that. They hear that as oh, well, that's kind of a nice to have. It devalues it, I think, in their eyes. And I've consciously tried to say, now, the goal here is to make the code easier to change. And I think that comes across better. And it's a little frustrating because I definitely, as you say, I experience it aesthetically, but that message doesn't seem to work very well with the people who are thinking dollars and cents.
Sure. I mean, if you talk to a chef about food and taste, they can explain it in ways that you can't possibly understand because you don't live in that world. And that's fine. I agree. I think this is part of the challenge of design has been that we have focused on technical aspects like coupling and cohesion. We haven't focused on, and so that means what? So the two things that I emphasize in my explanations, one is cost, and this is down to the Constantine equivalence, that the cost of software is roughly equal to the cost of changing the software, not initial development, which is irrelevant. So the cost of changing the software is roughly equal, for lots of fun and complicated reasons, to the cost of the big changes that we make to it. All the small changes that we make don't add up to anything like the cost of the big changes that we make. And the cost of the big changes is approximately equal to the coupling in the system. So the cost of software is roughly equal to the coupling in the system. So the cost reduction argument is we have a trade-off. You all know the international symbol for trade-off? Okay, there now you
I've seen you do that before.
So the trade-off is we have the cost of the coupling, which drives up exponentially, but we also have the cost of the decoupling, which drives up exponentially the other direction. And what we want to find is the minimum of those two functions. And that's the cost argument. But the other argument, which speaks to a different set of business people or executives, is optionality. The more we've driven up the cost of coupling, the fewer things we can implement cost effectively. So by driving down that curve, by investing in the structure of the software, we're creating options. Now, the thing about options is they have value whether or not we exercise them. Just having a portfolio of options. If I have a portfolio of stock options, I don't have any stock. But I can go to somebody with money who knows how to evaluate the value of those options, and they'll pay me money for nothing. There's no stock. Just as in a piece of software, there's no, let's say there are no features, but we could implement 10 different features, one of which is going to be very expensive. People will pay money for that. They'll pay money for what? For futures, for something that hasn't even been realized. Investing in the structure increases the value of software by increasing optionality in tangible money ways. Now, maybe we can't put it into a spreadsheet and say exactly how much that's worth, but kind of you can, because that's what VCs pay for, is the options on future growth. So those are the two ways. Instead of talking about aesthetics or my anxiety, which shockingly nobody who is paying me a salary cares about, I'm going to talk in economic terms. I can talk about cost reduction and optionality.
Wonderful. Thank you for your comment, friends. Again, if you'd like to participate in the conversation, just raise your hand on Zoom. And Hernan, welcome.
Hi, James, Kent. This is a different question, maybe, but how important do you think is doing TDD to be able to do a evolutionary design? Or maybe put it the other way, is it possible to do evolutionary design without having automatic testing or TDD?
So is it possible? Sure. People do it all the time. It's not possible to do is evolutionary design without feedback loops. And there's two main feedback loops. One is the behavior of the system, because you make small safe steps and every once in a while they're not safe. And the second is, so maintaining the behavior. And the second one is a feedback loop about the quality of the design. Okay, I tried to invest in decoupling. Did I actually succeed? Did I succeed for myself? Did I succeed for my team and the other people whose lives or work are affected by the decisions I'm making? And you have to have those feedback loops in place. TDD is a particular feedback loop that gives you feedback on both fronts. You could do that other ways if you want to. I don't care. I get people coming up to me all the time. Yeah, I read the TDD book and I don't really do it, and kind of mea maxima culpa. And I say, why in the world would I care? If you're happy with how you're developing it and you don't want it to get any better, knock yourself out. TDD, it's a skill. And if you haven't learned the skill, then it's really hard. And if you have learned the skill, then it's not. Okay. You choose.
All right. Harold has a comment. Harold, welcome.
I'm really excited by your book coming because I've been supporting architects in a company and really frustrated because that field seems not well understood in terms of this emergent design at all. And what I ended up finding was the Marie Kondo work, tidying, started to converge a lot with the idea of knowledge crunching. And I was just hoping you might speak more about that because this idea from Robert Martin about dependencies, and you want the central value, the core of your dependencies, so you're not leaning on things that change a lot, including frameworks like databases, and just having these things in the right order, like the tidy concept is everything in its place and a place for everything. And a lot of things are out of place, and that is a lot of aesthetics. And the tidying idea from Kondo, especially in this kind of Zen Japanese kind of mindset, very, very minimal, but with use in mind and honor and a lot. But the tidying seems to be very helpful, and I was hoping you'd say more.
Okay. And maybe you could also speak to the role of architecture in evolutionary design and how that all fits together, Ken.
Sure. I'm old enough that remembering two things is hard. So you may have to remind me. So tidying that language. So I was when I sat down to start writing this book, I had to figure out the central metaphor. And I found this clean and dirty, or clean and messy, to be too judgmental to be helpful. I was searching around Marie Kondo at the time. So I started writing 3 years ago, been at Gusto 3 years. And it was the 2 weeks before I started at Gusto. I had two unexpected weeks. So I just wrote every day and I got a bunch done, and then I stalled. We can talk about that process of book writing more if you're interested. But so I'm searching around for a metaphor, and Marie Kondo is very much in the zeitgeist at the time. So I realized that I really liked tidying as a metaphor. It's because it's small, it's approachable. You get the question all the time, oh, I can't get any time to refactor. Refactoring has become synonymous with expensive, of uncertain value, something the geeks want to do just because they don't feel like implementing any features anymore because they've gotten so slow at it. So I want tidying. Tidyings are cute, fuzzy little refactorings that you just, you can just rub on your cheek and make you feel better. So that was certainly in my mind. Also, I find tidying is optional. Yeah, So my desk is a little messy. I tidy it. I don't tidy it. It improves my life if I do, but it's not a disaster if I don't. So that's why I appropriated that metaphor, and I even published a piece called "The Life-Changing Magic of Tidying Up Code" as a homage to Marie Kondo. I did get I did a bunch of reading. If you're going to steal somebody's metaphor, you should do your homework. So I did my homework. I didn't get into the whole thing. I don't. Now, is that true? No, I bless and release books now, for sure. I thank them for their contribution to my life, and then I let them go contribute to society elsewhere. So I do a little bit of that. I'm not clear about taking a moment to thank a file before I delete it. But, it's worth an experiment. Who knows? So that's the sense in which the tidying works for me as a metaphor. And I have found it to be very helpful. I want people to get in the habit of designing software every day to make their lives better and to improve the value that they create. And tidying is just the first step of that. And we can, if you have questions about that and where this, what's going to be a series of books is going, we can talk about that in the future. So James, your question was about design and architecture.
Yeah, well, Harold had mentioned that he was figuring out how to work with architects. And thank you very much for your comment, Harold. And I wanted to just sort of riff on that, or ask you to riff on that, and say, one thing I hear from architects, and architects I know is a very fuzzy term, so define it however you like. But one thing I hear from architects is, our job is, to get things right. So the stuff that's hard to change is correct. That's one of the things I hear. And I'd love to hear what your thoughts are on the role of architecture and how it relates to evolutionary design.
I was fortunate to work at Facebook 2011 to 2018, before they destroyed democracy. I should take responsibility for my own small part in all of that. So, but here was the thing. Up until then, people would say to me, "Oh, this evolutionary design stuff, that's fine, but when you work at scale, you're going to have to blah, 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 blah."
It's the classic, I'm going to ignore your argument and shut it down type of comment, isn't it?
BNH, I call it. It's a corollary to not invented here. BNH means but not here. Means, sure, in theory you're right, but not in reality. And what I saw at Facebook was evolutionary design at the largest possible scale, unprecedented scale. You had a system that stored 100 billion photos, and you needed to replace it with a system that stored 1 trillion photos or 10 trillion photos, and you needed to do that without ever losing any photos, without ever having any downtime. Go. And Facebook, over and over and over and over again, accomplished that feat at unprecedented scale. So I saw evolutionary architecture at a scale that people would have thought was utterly impossible. So now I don't buy it when people say, "Oh, architecture is a whole different thing. You have all these irreversible decisions you have to make." No, you don't. When you have a gigantic system and you have to replace it with another gigantic system, or another one that would happen is you'd have parallel developments. Excuse me. So at one point, Facebook had 5 key value stores in production at scale. The API was, excuse me, exactly the same, get and put, and that was all there was to it. But there were 5 different ones. And going from 5 to 4 was a big project, and 4 to 3, and 3 to 2, and 2 to 1. This is countdown infrastructure, where you, for very good reasons, you have duplicate development, and you wait until they get big to figure out which of them that you want to unify. That's an evolutionary design at scale strategy. That's very much the opposite of what the architects. My stereotype of the architects is just wait till I get the enterprise scale key value store, and everybody just hold on. And then you lose all the opportunities you could be taking advantage of. The cost of delay at that point is enormous. And the architect who wants to upfront build the infrastructure that everybody's going to need is actually costing the company perhaps even its life by delaying the development of new behavior changes in the system. So I just don't buy it. My oldest is a software developer, and Z came to me one day and said, "People talk about architecture this and design that," and she said, "It's all just design, isn't it?" Oh, I raised you right. Oh, I'm so happy, because it is. It's beneficially relating elements, and if the elements are services, or if the elements are 2 expressions in the same statement, you have elements, you have a relationship, and you have benefit. And I mean, yeah, there's there's different technologies involved, but the fundamental skill is the same. Do you have coupling? Is it worth it to eliminate it?
There's a couple of things about what you said that I just love. One was you focused on that reversibility again. And I wonder if perhaps part of the job of the architect is to make things reversible rather than to focus on, oh, my job is to do the stuff that's unreversible. And the other thing that you said that I really, really want everybody to hear is that not to get in the way, not to delay decisions, not to stop change from happening, which of course was one of the reactions of XP and Agile, was all these processes that were all about stopping change, preventing beneficial change because of fear around what might happen if we don't do it all perfectly from the beginning. We still have people with comments, but unfortunately we are out of time. This has been a great conversation and I wish we had more time. Ken, I could talk to you all day. Thank you very much for joining us, Ken.
Oh, thank you so much, James, for hosting me. And thank you, everyone, for your questions. So you can find this book. Paid subscribers, this is the experiment I'm doing, is if a bunch of random strangers are giving me $7 a month, am I going to actually write instead of whatever else it was I was going to be doing? And the answer is, pretty much yes. So paid subscribers get finished chapters as they come out, usually one a week. And you can find that, the unpaid subscribers get teasers and commentary on the process and can ask questions and whatever else. So that's at tidyfirst.substack.com.
Kent is the creator of Extreme Programming, the basis of many of the Agile practices people use today. He's the author of many books. I recommend Implementation Patterns, and I'm very much looking forward to Tidy First, which again, you can find out more at tidyfirst.substack.com. Next week, we're going to be discussing situational awareness and teamwork. Jason Yip will be joining us for that conversation. Jason is a staff Agile coach at Spotify, and he's full of insights about coaching and teamwork, and it's sure to be a lively conversation. That'll be May 6th at 8 a.m. Pacific, next Friday. The Discord conversation starting today. You can join the Discord by visiting jamesshore.com/s/AOAD2. Discord. And also be sure to mark your calendars for the following week when Jessica Kerr will be joining us on May 13th to discuss building for operation. That is it for today. Thank you, everybody. Thank you, Kent. And I will see you all next week.